Have you ever looked at a picture of Earth from space at night? You see the continents lit up with city lights, a beautiful spiderweb of human civilization. But what if I told you that sometimes vast, empty patches of the ocean also glow, creating an eerie, Milky Sea visible even to satellites orbiting hundreds of miles above? This isn't science fiction. It's a real, mysterious phenomenon that has puzzled sailors for centuries and scientists for decades. Today, we're diving deep into the secrets of these glowing oceans. For hundreds of years, sailors have shared tales of navigating through vast, ghostly white seas. Imagine being on a ship, surrounded by an ocean that's not dark and black, but glowing with a uniform milky light as far as the eye can see. It's so bright you can read a book on deck. The famous author Jules Verne even described it in his novel 20,000 Leagues Under the Seas, calling it a Milky Sea. For a long time, these stories were dismissed as myths or tall tales from the sea. But in 1995, a satellite captured the first ever image of one of these events off the coast of Somalia. The glowing patch of water was enormous, larger than the state of Connecticut, and it glowed for 3 consecutive nights. Suddenly, the myths were real. So, what's causing this incredible spectacle? You might be thinking of bioluminescence, the beautiful sparkling light you see when you disturb the water at night, created by tiny plankton. That's a good guess, but it's not quite right. That kind of bioluminescence is flashy and temporary, like a camera flash. The Milky Seas are different. They produce a steady, constant glow that doesn't flicker or fade when the water is disturbed. The source is still bioluminescence, but on a scale and in a manner that is almost unimaginable. The culprits are a specific type of bioluminescent bacteria. These tiny, single-celled organisms are some of the most abundant life forms on Earth. And when they gather in absolutely colossal numbers, we're talking trillions upon trillions in a single patch of ocean, they can create this sustained, widespread glow. But here, is the mystery that scientists are still trying to solve. How and why do they all gather in one place and decide to light up at the same time? It's like a perfectly synchronized, ocean-sized light show. One leading theory involves a fascinating relationship between the bacteria and a type of microalgae, a phytoplankton called *Phaeocystis*. The idea is that these algae bloom in massive quantities, creating a huge food source. As the algae die and decompose, they release a treasure trove of nutrients. The bioluminescent bacteria then swarm to this feast, multiplying rapidly into a super colony. But why do they all glow together? This is where it gets even more interesting. These bacteria communicate using a process called quorum sensing. Think of it like a bacterial census. A single bacterium doesn't waste energy glowing on its own. It wouldn't be visible. But when they sense that a massive number of their kin are nearby, a quorum, they all switch on their lights simultaneously. It's a collective decision. This coordinated glow might be a strategy to attract fish. The fish eat the bacteria-laden detritus, and then the bacteria get a new, nutrient-rich home inside the fish's gut, where they can continue to thrive. The glowing ocean, in this sense, could be a giant eat here sign for fish. However, confirming this is incredibly difficult. Milky Seas are rare, unpredictable, and often occur in remote and sometimes dangerous waters, like the pirate-patrolled seas off the Horn of Africa. You can't just send a research vessel out to wait for one. It's like trying to catch lightning in a bottle. This is why satellite observations have been so crucial. Scientists can scan years of satellite data to find these ghostly patches of light and study their size, location, and duration. One scientist, Dr. Stephen Miller, has been at the forefront of this research. By analyzing decades of low-light satellite imagery, his team has been able to map out the hotspots for these events, primarily in the northwestern Indian Ocean and near Indonesia. They found that these events are most common during the monsoon season, when strong winds stir up deep, nutrient-rich water, likely triggering the massive algae blooms that kickstart the whole process. But even with satellite data, we are only seeing the glow from above. To truly understand what's happening, we need to be there, sampling the water. In 2019, a private yacht named Ganesha sailed through a Milky Sea near Indonesia. The crew was mesmerized. They described the glow as a soft, luminous field, as if they were sailing over clouds or a snowfield. They collected a water sample, and when scientists analyzed it, they confirmed the presence of a bioluminescent bacterium called Vibrio harveyi in a symbiotic relationship with the microalgae. It was the first time a sample had ever been collected from a confirmed Milky Sea event, providing a direct link between the theory and reality. The sheer scale of these events is what's truly mind-boggling. The energy required to light up an area of the ocean, the size of a small country, is immense. It is a powerful reminder of how much we still have to learn about the ocean and the microscopic life that governs its most fundamental processes. These glowing seas are not just a beautiful curiosity. They are a sign of a massive biological event happening just beneath the surface, an intricate dance of life and death on a microbial scale. These phenomena also have practical implications. The light is so significant that it can affect the entire marine ecosystem. It can confuse animals that use light to navigate or hunt. It could also be used to track ocean currents and the health of marine ecosystems from space. Understanding why these bacterial blooms happen could give us insights into ocean chemistry, nutrient cycles, and the base of the marine food web. So the next time you see a satellite image of our planet, remember that not all the lights you see are from our cities. Out in the vast darkness of the ocean, there are hidden seas of light, powered by trillions of tiny organisms communicating and collaborating to create one of nature's most spectacular and mysterious displays. It's a beautiful thought that even in the most remote parts of our world, there is a hidden, vibrant life that can literally light up the dark. We've only just begun to scratch the surface of understanding Milky Seas. Future satellite missions with more sensitive instruments and perhaps autonomous underwater vehicles could one day give us a front row seat to these events, finally solving the centuries-old mystery of the glowing oceans. Thanks for joining us on this deep dive. If you found this as fascinating as I did, hit that like button and subscribe for more explorations into the wonders of our world. See you next time